Hello everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of EC and Scientific Officer in the TIFAC Core at AKGEC Ghaziabad. So, we are studying subject microprocessor and microcontroller having code KEC 502. In this lecture, we will discuss the various addressing modes of 8085 microprocessor. So, this is the topic, this is the complex topic which we need to learn in our subject. So, so these are the table of contents that we will cover in this lecture. First one is the what are the various addressing modes of 8085. In this topic we will learn what is addressing modes, why we need to learn it. After that, addressing mode types with example. In this topic we will learn what are the various addressing modes, what are the types of addressing modes, and we will see some examples for more better understanding of the addressing modes. After that we will conclude and we will see the references. Now we need to know what is addressing modes of 8085. Before that, we should know there are two things in any instruction. Basically, instruction, what is the meaning of instruction? Instructions basically a set of commands, set of basically we can say instructions are the commands which microprocessor execute according, and they have to implement the instructions. So, in any instruction there are two things. First one is the opcode and the second one is the operands. Opcode means operational codes. So, opcode means that what the microprocessor has to execute upon receiving the instructions, that is the opcode. And operands means to whom it has to execute, that is the operand. So, basically opcode is a single, it may be any MOV, it may be MVI, it may be LXI, we have seen in a set of instructions. And operands are two, that is destination operand and source operand. In some instructions, destination operand is a part of an instructions, that is a exceptional case, and in some instructions there are no operands, that is the source and the destination operand are part of the opcode as well. So, there are two things, opcode and the operands. So, opcode basically we can say the commands which the microprocessor has to execute upon receiving it, and to whom it has to execute, that is the operand. So, operands are destination operand and source operand. So, the addressing mode means that the various ways by which we can access the operand by the opcodes is called addressing modes. As the name implies, addressing modes means various modes, various ways of addressing the operands by the opcode is called addressing modes. So, this is the basic thing. Now, we will start with the slide, that is to perform any action, we have to give the corresponding instructions to the microprocessor. So, that is the meaning of the instructions, because microprocessor is a machine. For every execution we need to send the commands. So, and the microprocessor behave according to the instructions we are giving it. So, every instruction of a program has to operate on a data. Obviously, in each instruction there are some data that need to be executed by the microprocessor. In each instructions, program has to specify three things: operation to be performed, address of source of data, and address of destination of result. That's I have already discussed. There are three things. Basically, opcode and operand are part of the instruction, but how the operand are executed by the opcode, this is the main thing. So, that is the definition of the addressing mode as well. So, operation to be performed, what type of operation has to carry by the microprocessor, it is specified in opcode, okay, operational codes. What the operation has to be performed by the microprocessor. Address of source of data, address of destination of result, that is we are talking about destination operand, address of destination of result, and a source operand. For example, in 808 microprocessor, data has to be shifted from source operand to the destination operand. So, we can say address of destination of result. So, that is we need to know the source of address of source of data and the destination operand. So, there are three things, and basically this is one, that is operand, this is operand. So, operands are two, okay. Now, the different ways in which a source operand is denoted in an instructions are known as addressing modes. I have already told that addressing means the various methods, the various ways by which the operands are accessed by the opcode is called addressing modes. So this is the definition of addressing mode. So finally we can say the method by which the address of source of data or the address of destination of result is given in the instruction is called addressing modes. So here we can say that opcode, operands. So we can say the method by which the address of source of data, here is the operands are two, destination operand and source operand. So we can say the method by which the address of source of data, that is this is the source of data which carries the values, which carries the memory location, which carries the 8-bit data, 16-bit data. So the method by which the address of source of data or the destination of result is given in the instruction is called addressing modes. So how the operands are accessed through the opcodes and the various ways by which opcode can address the operands is called addressing mode. So the addressing mode refers to the way in which the operand of the instruction is specified by the instruction is called addressing mode. How to address the operand by the instructions, the different modes is called addressing modes. Okay. So this is the definition of, this is the process of addressing modes. Now in this slide we will see what are the various types of addressing mode in any processor. Basically if we are specific to the 8085 microprocessor, then there are 5 addressing modes in 8085 microprocessor. In 8086 addressing modes will be more. 8051 addressing modes will be somewhat vary. So we are talking about the 8085 microprocessor. So Intel 8085, Intel is the company which has manufactured 8085 chips. That's why it is called Intel 8085. That was the first company which manufactured and commercialized the 8085 microprocessor chip. So there are 5 addressing modes in 8085 microprocessor. First one is the immediate addressing mode. Second one is the register addressing mode. Third one is the direct addressing mode. Fourth one is the register indirect addressing mode, and the fifth one is the implicit addressing mode. So for better understanding of the addressing modes, we are categorize all the addressing modes into 3 categories, that is group 1, group 2 and group 3. Group 1 is related to the addressing modes related to the register and immediate data. So if we are talking about the register, if we are talking about the immediate value that has to be moved into the destination operand, then this is related to group first. So group first is basically we are telling that these are the addressing modes for register and immediate data. If we are talking about the memory, if we are talking about the memory pointer or data is in the memory and it needs to be shifted into the destination operand, then we were talking about the direct addressing mode and register and indirect addressing mode. So basically these 2 addressing modes are associated with the memory locations. This is associated with the immediate value, that is 8-bit value or maybe a 16-bit value, and this is related to the registers. It may be 8-bit register or 16-bit, but if we are talking about the memory location, then they are specific, that is direct addressing mode, register addressing mode. Here I am writing here addressing modes for memory data. If we are talking about the memory location, we have to fetch the data from the memory, then it is a direct addressing mode and the register indirect addressing mode. After that there is another addressing mode, 5th one, that is the implicit addressing mode. It is related to the group 3, that is implied addressing mode. Implied addressing modes mean that implied, which didn't have any operands. In the beginning of the lecture, I have told that there are some instructions in which there is only a 1 operand, or there are some instruction in which there is no operand. That is the operand source and destination are part of the opcode, that is instruction. So that is the implicit addressing mode. That is a group 3, implied addressing modes. In further slides, we will see what is implicit addressing modes, and we will see all the types of addressing modes one by one. So let us start with the first addressing mode, that is the immediate addressing mode. Immediate means, as the name implies, immediate data. Immediate means we have to shift some things in immediate manner that will not be specified by any other register. That's why it is called a immediate movement of the data. So the syntax of immediate addressing mode is, this is the instruction, this is the instruction I. Okay, in instructions, as earlier I have told that there are 2 things, opcodes and the operand. Okay, Opcodes are telling about the operational codes, what the microprocessor has to do. I am already told that. And operands means there are two operands, source operand and a destination operand. So how the operand executed by the opcode is called addressing mode, but we are talking about the immediate addressing mode. So in immediate addressing mode, the immediate value, operand will be a value. The immediate value of operand is will move into the accumulator. Okay. So here this is example, MVI space A is the accumulator, 05H. So how we can recognize the immediate addressing mode? It will be recognized by the I. Basically, if we will not put a I here, then it is move. So here I implies immediate addressing mode. So immediate means that here the source operand will be a value, will be a data. Okay. So here 05 represent the immediate value, or we can say data. So through this instruction, we are moving the 8-bit value, that is 05H, into the accumulator register. Accumulator is a register. So you have seen that in any microprocessor or microcontrollers, accumulator by default should be included, because it is associated directly with the arithmetic logical operations. So what are the arithmetic logical operations we are doing? We have to include the accumulator register by default. So in immediate addressing mode, the immediate value, this is operand is the immediate value, will move into the destination operand. So here MVI is the opcode, A is the source destination operand, and 05 is the source operand. So here 05 value will move into the accumulator register if we are writing I here. If we delete I, or we will replace I with another value, if we will remove I, then we have to include the register here. Okay. So MVI is the operation, that is the opcode. What the microcontroller have to do? Microcontroller have to move the immediate data into another register. This is the meaning of the MVI. 05 is the immediate data. We are talking about the data, and this data will go into the accumulator register. So A is the accumulator. Another example is MVI M55H. So MVI M55H means we are moving immediate value. 55H is a immediate value. So we are moving the immediate value into the memory register, So here, because in 8085 microprocessor, we have seen that there are three things in any processor. First one is the CPU, another one is the input output, and the memory. So microprocessor can perform the input output operation and the memory operations. Okay. So they are getting the data, they may getting the data, they can access the value, or they can also access the memory locations as well. So M implies that it is a memory location. So we are moving, I means immediate. This is the in syntax we have seen, that is I, it should be followed by I. So I is the immediate value. So this 55 value will move into the memory register, so memory is not a register, memory location. Okay. So this is the meaning of immediate addressing mode. So we can say in immediate addressing mode, the data is specified in the instruction itself. The data will be a part of the program instruction. So we can say that the data is specified in the instruction itself, means that in case of MVI, I itself said that it is a value. So whatever we are moving into the accumulator register, it should be value. If we are writing MVI A, comma, let us consider some general purpose register here B, it is wrong. It is invalid. Microprocessor will not execute it. So the correct instructions is MVI A, comma, some value from 00 to FF. I am taking some 1A 55H anything. Okay. So this is the value. Another examples are MVI B 3H, move the data 3H given in the instruction to B register. B register is a general purpose register. LXI SP2700, LXI means we are loading the contents into the stack pointer register. So if we are loading into the stack pointer register is a 16-bit register. So the 16-bit contents will move into the stack pointer. So it will not be only 27, it will be a 2700. This is the lower byte, this is the higher byte. So in these instructions, we are we are moving the 2700, that is the value, into the stack pointer. Okay, so through this instruction, stack pointer is loaded by the 2700 value data. So how this is data? Through I. If we remove I, then it will be a memory location. So here this thing tell us that this is the value. ADI 45H, the 8-bit data operand is added to the contents of the accumulator and the result is stored in the accumulator. So ADI means, AD means addition, I means immediate value, and 45H will move into the accumulator. So basically add instructions, sub instructions, they are we will not need to write separately. We will not, just a second, I am taking the marker. We will not need to mention accumulator separately. So accumulator is a part of the instruction. So in the earlier I have told that there are some instruction which do not have any operand. In some instruction we have one operand. So accumulator is a part of the instruction. So by default we can say that here is an accumulator. So through these instructions we are moving the value. How we can say that it is value? Because here it is I. So we are moving the value 45H into the accumulator register. By default we have to consider it is the accumulator register. So similarly ACI 45H, the 8-bit data operand and the carry flag are added to the contents of the accumulator and the result is stored in the accumulator. Why? What is the meaning of result is stored in the accumulator? Whatever the operation we are doing, the result will store in the accumulator. Okay, because the meaning of the accumulator is that it will take accumulator result. So whatever the operations, arithmetic logical operations we are doing, the result will store in the accumulator register. So here we can say that if we are adding the 45H into the A, then A becomes A plus 45 and the contents of source operand will never be changed. Similarly, we have a SUI subtraction. We are subtracting the contents of 45H with the accumulator. Okay, SBI means we are subtracting the contents 45H with the accumulator. Okay, with borrow. Similarly, here C means with carry, here B means with borrow. In subtraction case, we are talking about the borrow. Okay, ORI means we are OR gate, OR operations. So logic operations. So we can say that logical operations. So we are OR the contents of 86H. Okay, 86H is a value with the accumulator register. Okay, so these are the some more examples. Now come to the register addressing mode. So in register addressing mode, as the name implies, both the operand, whether it is a destination operand or whether it is a source operand, both are registers. That is the meaning of the register addressing mode. So we can say in this addressing mode, the operand is in general purpose register. So here operands are general purpose register. So it may be B, C, D, E. We are avoiding HL because HL register pair is basically used for the as a memory pointer. So through this addressing mode, we are moving the contents of contents where lies in source operand. So we are moving the contents of register, source register into the destination register. So RAD is a destination register, RS is the destination register. So both are the registers. So we can say that how do we can say that these are the registers? Through MOV. We are moving the contents. If we instead of MOV, if we are writing MVI, then this is invalid because we if this is register, we have to move some value here. It should be some value, not a register. Okay. So in register addressing mode, the instructions specify the name of the register in which the data is available. So this is the syntax. In syntax, this is the opcode. What is the opcode? MOV, and registers means we are talking about the operands, source operand, destination operand. Here this is general purpose register. So RDRS is general purpose registers. So let us see the example. MOV A comma B. So through the instruction, B is the source operand. So this register, the contents of this register will move into the accumulator register. So move is the operation that tells the microcontroller to move something from somewhere, something into some another location, and B is the source of data, A is the destination. So move the contents of register B to A. So let us see some more examples of register addressing modes. MOV A comma V, we are move the content of B register to A register. Okay, some more registers are there, examples are there. SPHL, SP means stack pointer and HL is the memory pointer. So in architecture of 8085 you have seen we have 6 general purpose register B, C, D, HL, and we can pair some registers. Through pairing we will go into the 16-bit register. So the pairing rule is B will pair with the C and D will pair with the E and H will pair with the L. So there are 3 pairs and now it acts as a 16-bit registers. So out of these registers, HL register, HL act as a default memory pointer. So for memory related operations we have to include HL register pair. So here we are talking about this. So stack pointer basically which points to the stack of the data, top of the or bottom of the stack. So stack basically we are talking about the memory location. So these are the memory instructions. So through this instruction, load the content of HL registers into the stack pointer register. Okay. So after this instruction, whatever the contents H or L registers are carry, it will load into the stack pointer. It will load into the stack pointer. Okay. So add C, we are the contents of the register are added to the contents of the accumulator. If we are writing instead of D, if we are writing here A D I, then this is the immediate addressing mode because I is mentioned. Then we have to write some value here 54H etc. So this is the register addressing mode. We have to eliminate I and instead of that we have to write ADD, that is adding the contents of C register to the accumulator register. Here accumulator is a part of the opcode. Similarly, exchange the contents of register HL with the contents of register D. So through these instructions we are exchanging the contents of HL register pair with the general purpose registers. Some more instructions are INR. INR means incremental register. This is also the categorized into the register addressing mode. ANAR means we are performing the AND operation with the accumulator. So the contents of R register, general purpose register, will do the AND operation with the contents of the accumulator, and the result will be specified into the move into the accumulator. In this, through this operation, we will XOR the contents of general purpose register with the accumulator register. Similarly, we are ORing, that is we are doing the logical instructions XOR, XOR, NOR, etc. So we are ORing the contents of general purpose register. This is the register with the contents of the accumulator. So this is the register addressing mode. After that, another category is first group we have seen the register addressing mode and the immediate addressing mode. So now we are going towards the another group number second. The group second means we are talking about the memory location, as I have told you earlier. So in a direct addressing mode, we are talking about some memory location. So this is the syntax opcode. Here there is a difference. Instead of the value, that is we have seen in the immediate addressing mode, instead of the general purpose register, as we have seen in the register addressing mode, the operands will be a address. Okay. So address, we are talking about the address. So in direct addressing mode, the address of the operand, we are talking about the address of the operand, that is source operand. So the address of the operand will move into the destination register. So this is the syntax opcode. Here this is the destination operand. The difference is here one of the operand should be register, should be address. So that's why it is a direct addressing mode. So why it is called direct? Because we are moving the contents directly from some address location into the general purpose register. Similarly, the reverse vice versa will be happen. We are loading the contents of this register into the some address. It may be from 0000 H to FFH. Okay. So this is the example LDA 2500H. It means that we are loading this now 2500H is a we can say it is an address, okay, not a value. If for value we have to mention LDI. So LDA means that we are loading the contents of memory location directly into the accumulator register. So here I am writing LDA, let us say anything, any memory location 2500H. So we are loading the address, the contents of the memory location. This is the memory location. So here this is the memory location 2500H. So in this memory location, any contents will be there. For example, I am taking 0402H, any content. So we are loading the contents that lies in this memory location into the accumulator register through this instruction. So we are directly operating it. So that's why it is called direct addressing mode. So LDA is basically the operation which opcode which has to microprocessor execute upon receiving it. 2500H is the address of source, and accumulator is the destination. Okay. Some more instructions we will see. So in direct addressing mode, the address of the data is specified in the instruction. That is the 16-bit address or 8-bit address will lies into the instruction, will occupy in the instruction. So the data will be in memory. Okay. In this addressing mode, the program instructions and data can be stored in different memory. So another example is LDA 1050H. So we are loading the contents into from this memory location. This is the memory location. So in this memory location, there are some contents. So we are loading the contents from this memory location into the accumulator register. So load the data available in memory location 1050 into the accumulator. Similarly, we have seen SHLD. So SHLD means the contents of register pair. This is the register pair. So this is the memory location. So from this memory location, there are some contents we are storing into the memory location by the 16-bit address. Okay. So there are some contents, and through these instructions, it is moved into the some memory location. So HL is the register pair. It is act as a memory pointer. So I am taking, let us see from here, there is some stack, and HL register pair are there, HL. So HL register pair holds some value. So after this instruction, this value will go into the 3000H. So the contents of register L are stored into the memory location specified by the 16-bit address to the operand, and the contents of HL register are stored into the next memory location by incrementing the operand. So that means that after executing it, this will go into the next memory location. For example, if this is memory location 2000H, after executing it, it will go into the next memory location. Who will go? HL register pair. Okay. Similarly, we have a STA 4350H, store accumulator. The content of the accumulator is copied into the memory location. So store operations, we are moving the contents in the accumulator from the accumulator into the memory location. This is the memory location. So the contents of the accumulator are copied into the memory location specified by the operand. If we are replace LDA, then operation will be carried out from this to this. That is the 16-bit address will load into the accumulator. Okay. This is the register, direct addressing mode. After that, we have another category in group number 2, another addressing mode in group number 2. What is the group number 2? That is the memory operations, related to memory operation. So the another register, another addressing mode is register indirect addressing mode. So there are before that we have talking about the direct addressing mode. Here we are talking about the register and indirect addressing mode. So we are carrying out the operation indirectly. What is the meaning of indirect? We will see first. So in this addressing mode, the address of operand is specified by a register pair. So this is the syntax. In this syntax, you can see opcode. Okay. So now there is a difference. Instead of register and some memory location, there is some another pointer. There is some another location which acts as a pointer to the memory. So operations are executing indirect way. So instead of getting the data or value or memory location, there is some we can say that HL register pair which act as a memory pointer. And if for example there is some address 2050H, this address is pointed out by HL register pair and HL register pair, and from memory we are copying the data into the destination operand. Okay. So in Let us see through the example MOV A, M. So MOV A, M means that we have moved the data from memory location specified by HL register pair to accumulator. So memory location is a 16-bit. So it is pointed out by another register, HL register pair, and the contents of that we are moving into the accumulator register. So MOV is the operation and M is the memory location specified by HL register pair. So we have seen that HL register pair is the default memory pointer. So it is used to carry out the memory operations. So is the destination. Okay. If we instead of M, I am writing here B register, then this is the register addressing mode. The contents of register B moved into the accumulator register. So that's why it is called indirect addressing mode. Let us see with some example. So MOV A, M, the memory data addressed by HL register is moved into the accumulator register. LDX B, LDX means the contents of designated register pair point to a memory location. So copies of memory location into the accumulator. Store means we are copying the contents of accumulator register into the RP register pair. So register pair, this is register pair here. This is the register pair. Note the general purpose register. Move MA. Similarly, in the previous slide we have said move A, M. Here it is move M, I. Reverse will be valid. Okay, this is register indirect addressing mode. So in the register indirect addressing mode, the instruction specifies the name of the register in which the address of the data is available. Okay, here the address will be a memory and the address will be in the register pair. So we are talking about the memory operation. Now come to the last addressing mode, that is the implicit addressing mode. What is the meaning of implicit? That which didn't have any operands. Okay, operand is a part of the instruction. So if address of the source of data as well as address of the destination of result is fixed, then there is no need to give any operand along with the instructions. Why we do not need to mention any operand? Because if the address of the destination and the address of the source are same, we do not need to mention the operand in the instruction. So that is the implied addressing mode. So the instruction itself specifies the data to be operated. So this is the syntax here, these opcodes, and there is no operand. Operand is a part of the instruction itself. So this is the implied addressing mode. So example is CMA. CM means complement accumulator. So whatever the contents in the accumulator, for example, the contents of accumulator is 01001111. So after executed these instructions, it will complement, it will invert. So here 10110000. So is the source, this is operation, this is the destination. So some examples are complement the contents of accumulator, rotate accumulator left, rotate accumulator right through carry, exchange the content of HL register pair with D register pair, rotate left, rotate right, complement carry, set carry, read interrupt mask, set interrupt sum. Here one thing is common. There is no operand. Operands are the part of the instruction. So the conclusion is addressing mode means the various ways by which we can access the operands by the opcode is called addressing modes. Okay. So how the different methods by which instructions executed the operands is called addressing modes. So these are the references, Ramesh Khonkar and Kenneth L. Short.